Good afternoon, children. This is Ajit Kumar. Hope you are all fine. And let us have a quick revision on all the physics topics today. And let's start our discussion with the topic heat. So, coming to heat, we already know what is heat. So, heat is a form of energy in transit which always flows from a body at a high temperature to a body at a low temperature. So, heat always flows from high temperature body to low temperature body. So, heat is a form of energy in transit which always flows from a body at high temperature to a body at a low temperature. Coming to the units of heat, we already know the simplest unit is calorie and SI unit is joule. The relation is 1 calorie is equal to 4.186 joules. So this is about the heat energy. So heat is a form of energy in transit which always flows from a body at high temperature to a body at low temperature. And what is calorie? We already know the definition of calorie. That is, a calorie, the amount of heat required to convert 1 gram of water, to raise the temperature of 1 gram of water by 1 degree Celsius. If I have 1 gram of water at 27 degree Celsius and I want to make it 28 degree Celsius, that means I want to raise the temperature of this water, 1 gram of water by 1 degree Celsius. For this I require some heat energy. That heat energy we call it as calorie. And the next one is temperature. And what is temperature? The next one is temperature. The degree of hotness or coldness. It determines the degree of hotness or coldness of a body. So, the temperature says how hot or how cold is a body. And coming to the units of temperature. The CGS unit is Celsius and SI unit is Kelvin. The CGS unit is Celsius and SI unit is Kelvin. The relation is Kelvin is equal to C plus 273. Kelvin is equal to C plus 273. That is 0 degree Celsius is equal to 273 Kelvin. That means in order to convert the Celsius into Kelvin, we have to add the 273. In order to convert the Kelvin from Celsius, we have to subtract 273. Let us see two examples. So convert 30 degrees Celsius to Kelvin. So K is equal to C plus 273. So the C value is 30. This is plus 273. So the answer will be 303 Kelvin. The answer will be 303 Kelvin. And now we can convert the Kelvin into Celsius. For example, convert 343 Kelvin to degree Celsius. Convert 343 Kelvin to degree Celsius. So we have to subtract 273 when we want to convert from Kelvin to Celsius. So C is equal to K minus 273. That is 343 minus 273, which is 70 degree Celsius. So in this manner we can convert Celsius to Kelvin and Kelvin to Celsius. And next we have some important activities in the heat lesson. That is activity 3, activity 4 and activity 5. The activity 3 in the heat lesson gives about the relation between the temperature and the absolute temperature and kinetic energy. So in this activity we will take 2 beakers of water. One is cold water and one is hot water. Now pour some food color in both the beakers. So observe the movement of the fluid particles in both beakers, in the beaker in which we have placed cold water and the beaker in which we have placed hot water. You can observe that the particles in the hot water moves faster. The particles in the hot water will move faster because it has high temperature, and the particles in the cold water will move slower because it has a low temperature when compared to in comparison with these two beakers. So what we can observe is the average kinetic energy of the molecules. The average kinetic energy of the molecules. What is kinetic energy? The energy possessed by a body due to its motion. So the average kinetic energy of the molecules is directly proportional to absolute temperature. Absolute temperature. What is absolute temperature? So the temperature which is expressed in Kelvin scale is called absolute temperature. This is what we can conclude from activity 3. Next, the activity 4 in the chapter will explain about the heat and temperature. In this experiment, in this activity, we will take hot water. Let the hot water be at 80 degrees Celsius. Now try to pour oil on the surface of the water. We know the density of oil is less than the density of water, such that the oil will flow on the surface of the water. Now place thermometers in both the oil as well as water. The hot water will show a rise of the level of mercury at 80 degrees Celsius, as the oil at room temperature may show about 27 degrees Celsius. And as the time goes on, we can observe that the level of mercury in the hot water goes on decreasing and the level of mercury in the cold oil goes on increasing. From this we can say that the heat energy is flowing from water to the oil. How we have concluded that? We have concluded that by looking at the temperatures in the thermometers. So we can say that temperature determines the direction of the heat flow, whereas heat is the energy that flows. So from this activity we can conclude that the temperature determines the direction of heat flow, whereas heat is the energy that flows. Next, the activity 5. The activity 5 explains that the rise of temperature for all substances is not same. The rise of temperature with respect to the same amount of heat supplied, when same amount of heat is supplied to two different substances, the rise of temperature will not be same. For example, take a beaker and pour some hot water. Let this hot water also at 80 degrees Celsius and place one boiling tube filled with oil and another boiling tube filled with water and oil. Both are at room temperature. Let's see, the hot water at 80 degrees Celsius is filled in this beaker, and two boiling tubes are taken, and one filled with oil and one filled with water at room temperature. Now place two thermometers. Place two thermometers in both oil and water in both boiling tubes. What you can observe is the rise of temperature is faster in oil when compared to water. We have supplied same amount of heat to the both of the boiling tubes, but the rise of temperature is faster, is rapid in the oil when compared to water. From this activity we can conclude that the specific heat capacity depends on nature of the substance. Now let us see what are the factors influencing the amount of heat. What are the factors influencing the amount of heat? So the first factor is mass. More is the mass, more is the heat required. More is the mass, more is the heat required. The second factor is the change in temperature, delta T. So Q is directly proportional to mass when delta T is constant, and Q is directly proportional to delta T when mass is constant. Here delta T is constant and here mass is constant. From 1 and 2 equations we can write Q is directly proportional to m delta T. Q is directly proportional to m delta T. So Q directly proportional to mass of the substance, and Q is directly proportional to the change in difference, where Q is the amount of heat required. And in order to remove the proportionality, we multiply with a constant, and this constant is S. So we can write the equation as Q is equal to ms delta T, where S is proportionality constant called specific heat capacity. Now what is specific heat capacity? The specific heat capacity is the amount of heat. We already discussed about the definition of calorie. Similar to calorie, in the calorie we take 1 gram of water, but here we will take 1 gram of any substance. So we can write the amount of heat required. The amount of heat required to raise the temperature of 1 gram of any substance. 1 gram of any substance by 1 degree Celsius is called the specific heat capacity. So the amount of heat required to raise the temperature of 1 gram of any substance by 1 degree Celsius is called specific heat capacity. For example, if I have supplied the same amount of heat to 2 different substances, they cannot have same rising temperature. For example, I have taken lead. I have taken lead and I have taken water. Initially both are at 27 degree Celsius. Initial temperatures of both lead and water is 27 degree Celsius. But to reach to 28 degree Celsius, to reach to 28 degree Celsius, lead required 0.003 calorie of heat energy, but water required 1 calorie of heat energy. Okay, and similarly ice or vapor or kerosene, they require 0.5 calories in order to have same rise in temperature. 1 degree rise in temperature, different substances will require a different amount of heat. This amount of heat we call it as specific heat capacity. This is the reason why the watermelon stays cool for a long time after keeping out of the refrigerator, why the sand cools faster and gets hot faster at the beach during sunrise and sunset times, and why the popcorn cooks faster. All these are examples of specific heat capacity. Why the samosa is stays inside hotter and outside colder. All these are examples of the specific heat capacity. And next, we are going to discuss about the principle of Metropia mixtures. According to the principle of Metropia mixtures, the net heat lost by hot body is equal to the net heat gained by cold body. So when two bodies are there, let it be 60 degrees Celsius and let it be 40 degrees Celsius, having same mass with 60 degrees Celsius and 40 degrees Celsius, then they are made into thermal contact. The heat will flow from body A to body B. As it is high temperature, as it is having low temperature, the heat will start flowing from high temperature to low temperature. This temperature will travel until they attain the same temperature. Then they reach the same temperature. That point we call it as thermal equilibrium. It is the state of the body where it neither receives nor gives out the heat energy. And from this we can say the thermal equilibrium will be at 50 degree Celsius. Because according to the principle of Metropia mixtures, the net heat lost by hot body is equal to the net heat gained by cold body. Next, let us see the conversions of the states. We have the matter is converted into 3 states: solid, liquid and gas. So conversion from solid to liquid, liquid to gas, gas to liquid and liquid to solid. So when you when you supply heat energy to solid, it converts into liquid. This process we call it as melting. When you supply heat energy to liquid, it converts into gas. This process we call it as boiling, and this we call it as condensation or liquefaction, and this we call it as freezing. So this we call it as evaporation also. Then what is the difference between boiling and evaporation? What is the difference between boiling and evaporation? We can observe that if you have pour some water on the floor, it gets converted into gas. But there is no amount, there is no heat transferred, there is no heat supplied to the water. It, according to the conditions of the atmosphere, the water gets converted into gas state. This we call it as evaporation. That means in boiling, the liquid converts into gas. In the evaporation also, the liquid converts into gas. But the boiling takes place at a particular temperature. For example, the boiling point of water is 100 degrees Celsius. So when the process takes place at particular temperature, that we call it as boiling. When it takes at any temperature, that we call it as evaporation. Evaporation is a cooling process. Evaporation is a surface phenomena. And what are the factors of affecting the evaporation? The surface area is affecting the evaporation. So that is the reason why we prefer to sip a hot tea in saucer rather than a cup. And the dog's panting is an example for evaporation. Why do we sweat during doing work? That is also evaporation. So evaporation is a cooling process. And next, coming to the condensation. This is the reverse process of evaporation. It converts gas to liquid. Evaporation is a cooling process. Condensation is a warming process. So the gas converts into liquid. So for example, if you have taken a chilled bottle from the refrigerator and keep it outside on the table for some time, then what you will observe is the few dew droplets are found on the surface of the bottle. So this is because of the vapor around the bottle condenses on the water bottle. So it forms the water droplets on the surface of the bottle, and when it fills with the water droplets are formed on the surface of our body. When you stay after bath, after the bath, still you stay in the shower stall, you can observe that the water droplets are formed on the body. So all these are examples for the condensation. And similarly, during winter seasons, the water droplets are formed on the surface of the windows, leaves, on the trees, on the vehicles which are parked outside. So you can observe the water droplets. So this we call it as this is due to condensation. During condensation, we can form dew and fog. What is dew and what is fog? We have already discussed that water droplets are formed on the surfaces are called dew. So the water droplets require a surface to get condensed. But the water molecule during winters, the vapor molecules in the atmosphere require a surface. So if there is no surface, then they uses the dust particles in the atmosphere for condensation, and they form a mist layer. This thick mist layer we call it as fog. This fog will affect the visibility, but dew will not affect the visibility. Okay, next coming to the latent heat. Latent heat. So we already discussed for converting solid to liquid and liquid to gas and gas to liquid and liquid to solid, we require some heat energy. It may be absorb heat energy or we have to release the heat energy. So this energy to convert one state from another state. So the amount of heat required to convert one state to another state is called latent heat, and this is again classified into two types, that is latent heat of vaporization and latent heat of fusion. Latent heat of vaporization and latent heat of fusion. So the amount of heat required to convert liquid into gas, 1 gram of liquid into gas is called latent heat of vaporization, and the amount of heat required to convert 1 gram of solid into liquid we call it as latent heat of fusion. The value of latent heat of vaporization of water is 540 calorie by gram, and the latent heat of fusion of ice is 80 calorie by gram. That means it requires 540 calories to convert 1 gram of water into vapor. Similarly, we require 180 calories to convert 1 gram of ice into water. So this is about heat, and let us move on to the next lesson, that is refraction of light at plane surface. Refraction of light at plane surfaces. So we are well known that the light has different properties like reflection, refraction, diffraction, scattering, dispersion. We have different properties of light. Among that we have refraction. So what is refraction? We can observe that when I have watched a doll falling in the swimming pool, the position of the doll appears somewhat higher than its original position. And when you have taken a glass of water and you have placed a straw in it, you can see the straw appears bent. Why does this happen? Is the straw getting bent? No, actually the light is getting bent when it's traveling from one medium to another medium. This process of bending of light when it travels from one medium to another medium is called refraction of light. The process of bending of light when the light travels from one medium to another medium is called refraction of light. Why does the light bend? Because the speed of the light changes when it travels from one medium to another medium. For example, we cannot run with the same speed at every place. For example, we can run with some speed on the dry floor, and we cannot run with the same speed in the same sand, and we cannot run with the same speed in the water. So as similar to us, the light also changes its speed from one medium to another medium. Actually the speed of light in vacuum, is 3 into 10 power 8 meter per second. So it almost travels 3 lakh kilometers in 1 second. The light travels 3 lakh kilometers in 1 second. So the fastest in the universe is the speed of light. So this speed of light changes from one medium to another medium. So due to this, the light appears bent. So this process of bending of light is called refraction. Let us see what happens when the light is traveling from rarer to denser. So consider two mediums, rarer medium and denser medium. Which is rarer and which is denser? So when you have compared two different mediums, the medium which have less speed is called denser medium, with the medium which has more speed is called rarer medium. When the light is traveling from rarer medium to denser medium, at the point of interface of the two medium, you have to draw the normal. So this is the incident ray. When the light is traveling from rarer medium to denser medium, it bends towards the normal. So what are the factors changing? When the light is traveling from rarer to denser, the speed decreases, wavelength decreases. What remains constant? The frequency remains constant. When the light is traveling from one medium to another medium, the frequency remains constant. So what happens when the light is traveling from denser to rarer? When the light is traveling from denser to rarer, it bends away from the normal. So this is the incident ray, this is the refracted ray. The angle between the normal and the incident ray is called the angle of incidence. The normal and the refracted ray is called the angle of refraction. Here the angle of incidence is greater than angle of refraction. And here the speed increases, the wavelength increases, and here the frequency is constant. And angle I is less than angle R. Angle I is less than angle R. So when the light is traveling from denser medium to rarer medium, the speed increases, the wavelength increases, and here also the frequency remains constant. So with respect of the speed of the light, the frequency is remaining constant, and the angle of incidence is greater than angle of refraction. Here angle of incidence is less than angle of refraction in second case. So will it be possible to be angle I is equal to angle R? Is it possible? Will angle of incidence and angle of refraction are will be is the possibility of they are becoming equal? So this we will discuss as the conditions for no refraction. Conditions for no refraction. What are the conditions for no refraction? The first one is, even though light ray traveling from one medium to another medium, let it be medium 1 and medium 2, if the light ray is incident on the normal, the light ray is incident on the normal, the light will not bend. The light will not bend. So here the angle of incidence is equal to angle of refraction. Here angle of incidence is 0. Here angle of refraction is also 0. So in this condition angle I is equal to angle R. And also we have the second rule, that is, even though it is not incident on the normal, the light ray may go straight. Angle I is equal to angle R when the refractive indices of the two media are same. And the refractive indices of the two media are same, or the speeds of the two media are same. So these are the two conditions. Next, what is refractive index and what is relative refractive index? So refractive index is it is a ratio between the speed of light in vacuum and the speed of light in a given medium. This we call it as the refractive index. The speed of light in vacuum is a constant value. This is 3 into 10 power 8 meter per second. And we will be given according to the problem. So by depending on this, we will be having some problems. This is absolute refractive index. Coming to the relative refractive index, this is the comparison of two different medium. So we can write it as N2 by N1 or V1 by V2. So we can define it as the speed of light, the ratio between speed of light in first medium to the speed of light in second medium is called relative refractive index. And next we will discuss about the laws of refraction. Laws of refraction. So the light will follow two laws in refraction. The first law we call it as the incident ray, the refracted ray, and normal lies on the same plane. And the second law we call it as Snell's law. Snell's law. This states that the ratio of sine of angle of incidence and sine of angle of refraction is always constant, and this constant is the refractive index. So the sine of the ratio between sine of angle of incidence and sine of angle of refraction is always constant. For this we have a lab activity that we will take a semicircular glass lamp and draw its outline on the chart, and take a by removing this take a compass and draw the markings. Draw the protractor, take a protractor and draw the outline of the protractor and write the readings. Okay, now place the glass lamp and by using a laser incident the light at this point at different angles, like be 5 degree, 10 degree, 20 degree and so on. And for every angle of incidence note down the angle of refraction and find out the value of sin I and sin R ratio. So what you can observe is, for every angle of incidence we will get some angle of refraction, but their sin value, the ratio of their sin values, it will remain constant. That we call it as the refractive index. So this is the lab activity of Snell's law. Next we have lateral shift, and we have special conditions regarding when the light ray travels from lesser medium to rarer medium. When the light ray travels from denser to rarer, we have discussed that it moves away from the normal. So when the light ray travels from denser to rarer, it moves away from the normal. When I have increased some angle of incidence, then the refracted ray falls on the interface, so the angle of refraction will become 90 degrees. So the angle of incidence at which the angle of refraction becomes 90 is called critical angle. Is called critical angle. And if I further increase the angle of incidence, then the light gets reflected into the same medium. So here the angle of incidence is greater than the critical angle. So what happens? The total internal reflection takes place. So the process of bouncing of light into the same medium is called total internal reflection. So mirages, the brilliance of diamond and optical fibers, all these are some examples of total internal reflection. Next we have a lateral shift and vertical shift. Lateral shift. So when you have taken a glass slab, place two pins here. Now try to place another two pins by looking into the glass slab, and now remove the glass slab and try to join these lines. So you can observe this. They are not in the same straight line. So why? Because when the light ray traveling from direct to denser, it bends towards the normal. And when the light ray travels from denser to rarer, it bends away from the normal. So that this is the actual incident ray, extended incident ray, and this is the emergent ray. The outcoming ray we call it as emergent ray. So there is some difference between the extended incident ray and the emergent ray. This distance we call it as a lateral shift. The distance between the extended incident ray and the emergent ray we call it as a lateral shift. And coming to the vertical shift. Take a glass slab and place a pin at the point P. And by looking into the glass slab, try to place another pin at the same point of P, and try to place here. When you look here, the positions of the P and Q will not be at the same position. They may vary. Okay, so this is the exact position of the pin and this is the apparent position of the pin. So this difference between, or this distance between the the exact position and the apparent positions are called as vertical shift. By finding this vertical shift, we can find the refractive index of the glass slab. So the formula is the refractive index is equal to thickness of glass slab by thickness of glass slab minus vertical shift. So this is about some important points regarding refraction of light at plane surfaces. Now let us discuss the next unit, that is refraction of light at curved surfaces. Refraction of light at curved surfaces. So we have discussed that when the light ray is incident on a plane surface, depending on the speed or depending on the refractive indices of the two media, it may bend towards the normal or it may bend away from the normal. Okay, but what happens if the same light is incident on a curved path? If the same light is incident on a curved path, let's see. So I have taken a curved path which is separating the rarer medium and denser medium. So this point we call it as, the point of incidence we call it as a pole. Okay. The center of the curved path, let be the center of curvature. Now join this one, this we call it as the principal axis. This we call it as principal axis. Now when the light ray is incident at some point, where should be the normal drawn? the normal should be drawn from the center of curvature to the point of incidence. So this we call it as the normal. When the light ray travels from rarer medium to denser medium, actually this is the straight path. According to Fermat's principle, it goes in a straight line. But from rarer medium to denser medium, it bends towards the normal. So it bends towards the normal. It may change its path. So in this there are some conditions. When the light rays passing parallel to principal axis goes through focus. When the light rays passing parallel going through focus, it goes parallel to principal axis. When the light rays passing through optical center, it goes undeviated. And these are some rules which we follow. And what are the formula for refraction of light at curved surface? That is n2 by v minus n1 by u is equal to n2 minus n1 by r. So where v is the image distance, u is the object distance, and r is the radius of the curved path what we have taken. So this is the formula, this is the relation which gives among the relation between the image distance, object distance, and the radius of curvature with the help of the refractive indices of the first medium and second medium. And this is for curved surface. For a plane surface, the radius is infinity. For a plane surface, the radius is infinity. So that this becomes n2 by v minus n1 by u is equal to something by infinity 0. So we can write n2 by v is equal to n1 by u. So this is the formula for refraction at plane surface. This is for the refraction at curved surface. Okay. Next. Now let us discuss about lens. What is a lens? We have seen this is a curved surface and this is a plane surface. Then what is a lens? A lens is a transparent substance which can be formed by the combination of one curve and one plane surface or two curved surfaces. So lens is a transparent media which can be formed by the combination of two curved surfaces or one plane and one curved surface. So the lens can be formed by two curved surfaces in this manner. In this manner. So when it is formed, this we call it as the biconvex lens. This is biconcave lens. This is plano-convex and this is plano-concave lens. So the lens is a transparent medium which is formed by the combination of two curved surfaces or one plane and one curved surface. Let us see the parts of a lens. So in order to make it easy, the convex lens we call it as a converging lens. The convex lens can be denoted by the outward arrows and the concave lens can be denoted by the inward arrows. So this is the convex lens and this is the concave lens. The center of the lens we call it as the optical center. Optical center. So we already discussed that when the light ray is passing parallel to principal axis goes through focus. So when the light ray is passing parallel to principal axis, they will converge at a point. This point can be called as focus. And double this value we will write it as 2f. Similarly, when you incident the light around this way, you have another focus and this is 2f. And if you have taken lens in this manner, this is the first curved surface. So this is f1, this is 2f1. And this is the second curved surface, this is f2 and 2f2. Similarly, for this, this is the first curved surface. So here we have f1 and here 2f1. This is f2 and 2f2. So these are the positions of the lenses, the parts of the lenses. So that all this the distance from optical center to focus is called focal length. The distance between the optical center and the center of curvature is called center of curvature. If I have placed an object here, the distance between optical center and the object is called object distance, and the distance between object and if the image is formed here, the distance between optical center and image distance is called image distance. Okay. And we have some sign convention rules. We have some sign convention rules that because there are all the distances must be measured from optical center or pole. All the distances must be measured from optical center. The distances measured in the direction of incident ray are taken as positive, and opposite to the direction of incident ray are taken as negative. The distance, the size measured above the principal axis is positive, and the size measured below the principal axis is negative. For example, if I want to measure the optical center, object distance from the optical center. So the incident rays are going in this manner, but I want to measure according to the first rule. All the distances must be measured from optical center. So we have to measure opposite to the incident ray. So the object distance is minus u, and if I want the image distance, I am following the direction of the incident rays. So the image distance is positive, and if I want the height of the object, I am measuring above the principal axis. So it is height of the object is positive, and below the principal axis height of the image will be negative. So these are the sign convention rules. Now let us see the ray diagrams for different conditions. We have 6 conditions for convex lens and 2 conditions for concave lens. For example, here we have placed the object beyond 2f2. Beyond 2f2. So we have taken 2 rules. The light rays passing parallel to principal axis will go through focus, and when the light rays passing through optical center goes undeviated, or when the light rays passing through focus it goes parallel to principal axis. Among these rules we can use any 2 rules and trace the image. So here in the first condition we have placed the object beyond 2f2, the image is formed between f1 and 2f1. In the second case I have placed the object at 2f2, and by using the 2 rules the image is formed at 2f1. The third case I have placed the object between 2f2 and f2, so that I have placed the image is traced beyond 2f1, and when object is placed at focus the image is formed at infinity. And this is the most important case, that is on all these cases the images formed are real and inverted, but only in this case of convex lens the image will be formed as a virtual image. Okay, only in the 6th case the image formed is a virtual image. So here by using 2 rays I have taken, one is from optical center and another one taking parallel to principal axis and goes through focus. When I extend these rays as they are getting diverged, I have extended back these rays, then what I got is a virtual image. So this is the important image. Some questions may be asked to draw the why the lemon appears bigger when it is placed in a glass of water. So you have to explain with this diagram. Also, how can you explain how a palmist watches your palm, so that these conditions can be explained by this diagram. And the next one is concave. Concave we have 2 conditions. The first condition we already know, when the object is at infinity. When the object is at infinity, the image will be formed at focus. And the second condition, when the object is placed anywhere, the object is placed anywhere between infinity and the optical center, the image will be formed between the object and the lens. Object and the lens. Okay. Next, how to find the focal length of the lens. So we know that we can find the focal length of the lens by UV method. By using UV method we can find the focal length of a biconvex lens. So we have, what you have to take is a V stand, a lens, convex lens, and candle, meter scale, a table. Okay, this is what you have to take and place the lens on the V stand and light on the candle and ask your friend to move the candle and you have to place a screen on the other side of the lens. So try to trace the sharp image of the candle on the screen. So where you have, at what distance you have got this image, so that will be the focus. So by measuring the distance between the lens and the screen, what you can get? You can get the focal length of the lens. So by placing the object at different distances and by tracing its image by using the screen, so that you can find the focal length of the lens by using this UV method. So this is object and image method. So by placing the object at different distances, you are tracing the image by measuring that by using the formula, lens formula, 1 by f is equal to 1 by v minus 1 by u. By placing the object distance and image distance, we can find the focal length of the lens. So v is the image distance, u is the object distance. So by using this formula is called the lens formula. 1 by f is equal to 1 by v minus 1 by u. And how does the focal length change according to the surroundings? What happens when it is placed in water? So when you have placed when you have taken a beaker and place a stone here and by using a lens holder, place the lens and try to wash the stone in the lens. So you can find the image of the lens at a certain distance. Now pour some water in the beaker and at a position of 4 times focal length of the lens. You cannot after that you cannot observe the lens, you cannot observe the image. Why? Because the focal length changes, the focal length of the lens changes depending on the surrounding medium. So the focal length of the lens increases, when it is placed in water. Next we have lens maker's formula. So we know lens makers. Who makes us the lens? So they use this formula to find the lens power of the lens. So you know 1 by f is equal to power. So 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. This formula we call it as lens maker's formula. This is lens maker's formula and this is a lens formula. Now let us move on to the next lesson. That is human eye and colorful world. Human eye and colorful world. So human eye and colorful world. Now first we will start our discussion with the least distance of distant vision. So at a certain distance we can see an object clearly and without feeling much stress. So that we call it as the least distance of distant vision. Actually this is 25 centimeter for an adult healthy person. The least distance of distant vision is 25 centimeters, and this value changes from person to person and with aging. This value will be 7 to 8 centimeters for children, and it will be 1 meter to 2 meter or sometimes even more for old people. So the value of least distance of distant vision changes from person to person. And also we have angle of vision. The angle of vision, we can see an object at an angle of 60 degree. So this is also an average value. This also changes from person to person. Now let us discuss about the structure of eye. Structure of human eye. So this is the structure of human eye. So in this structure we have cornea. The cornea acts as a protective membrane. The cornea acts as a protective membrane for the human eye. And next we have a layer between the cornea and the lens. So this is filled with a jelly like substance. This we call it as aqueous humor. Next we have a convex lens in our eye. This lens is a biconvex lens, and we have a iris. So what does iris do? Iris adjusts the size of the pupil. What is a pupil? Pupil is a small hole. Pupil is a small hole in the center, at the center of the lens. So the amount of light entering into the eye can be adjusted by the pupil. So by the iris. What does iris do? The iris adjusts the size of the pupil. Okay. Next we have ciliary muscles. So what does the ciliary muscles do? So we know that we have eye lens. So this eye lens is not having a fixed focal length. The focal length of the biconvex lens can be varied by using ciliary muscles. So what is the functioning of ciliary muscles? The ciliary muscles adjust the size of the focal length of the eye lens. So by this we can see the object at different distances, because the lens is here and here is the retina. So the distance between lens and the retina is 2.5 centimeters. The distance between eye lens and the retina is 2.5 centimeters. That means the image distance is fixed. The object may vary. Okay. So in order to balance this, 1 by f is equal to 1 by v minus 1 by u. If this is fixed, the v value is fixed. If with change in the object distance, what must be changed? The focal length must be changed. This is performed by ciliary muscles, so that we can see the objects at a different distance. If these ciliary muscles are not there, we can see objects only at particular distances. And the retina acts as a screen for the human eye. The retina acts as a screen for the human eye. And we have the retina screen means it always catches inverted images. So this inverted image can be again inverted by the optic nerves and sent to our brain. So this is the structure of the human eye. So this is what happens. This is what happens in our human eye to get an image. So this human eye has some defects with the improper functioning of ciliary muscles. Actually, with the functioning of ciliary muscles, the maximum focal length of the eye lens is 2.5 centimeter and the minimum focal length of the eye lens is 2.27 centimeters. So the focal length of the eye lens can be decreased up to 2.27 centimeters and be increased up to 2.5 centimeters. But by the improper functioning of this ciliary muscles, our eyes may suffer, our body may suffer with different defects. These defects are myopia, hypermetropia, and presbyopia. So these defects are myopia, hypermetropia, and presbyopia. So myopia we call it as short-sightedness. Hypermetropia we call it as long-sightedness. Presbyopia we call it as it is the combination of both myopia and hypermetropia.
డైరెక్టర్ అనపర్తి ప్రకాశరావు గారి నిరంతర పర్యవేక్షణలో అత్యుత్తమ ప్రమాణాలతో క్రమశిక్షణతో కూడిన విద్యను అందిస్తున్న సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. లైబ్రరీ, కంప్యూటర్ ఎడ్యుకేషన్, ప్రొజెక్టర్స్, హై అండ్ ల్యాబ్ ఎక్విప్మెంట్ తో పాటు రక్షణాత్మకమైన రవాణా వ్యవస్థను కలిగి ఉన్న నమ్మకమైన సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. ఎస్ఎస్సి వార్షిక ఫలితాలతో పాటు జాతీయ, అంతర్జాతీయ ఒలింపియాడ్లో అగ్రస్థాన ఫలితాలను సాధించడంలో దిట్ట. క్రీడలు మరియు ఇతర సాంస్కృతిక కార్యక్రమాలైన నృత్యం, సంగీతంతో పాటు క్రాఫ్ట్ వర్క్స్ లాంటి కళాత్మకమైన అంశాలకు ప్రాధాన్యత ఇస్తూ ఆర్చరీ, రైఫిల్ షూటింగ్, స్కేటింగ్, ఫెన్సింగ్ లయందు జాతీయ స్థాయి శిక్షణ కల్పించడం మాంటిసోరీ ప్రత్యేకత. పరిశుభ్రమైన పౌష్టికాహారం, అత్యంత పరిరక్షణతో కూడిన హాస్టల్ వసతి కలదు. మాంటిసోరీలో చదువు ఉన్నత విలువల కొలువు. మీ పిల్లల భవితకు మాంటిసోరీ భరోసా. అడ్మిషన్లకు సంప్రదించండి. మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ ఇంగ్లీష్ మీడియం, బ్యాంక్ కాలనీ, తణుకు. మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు పచ్చటి పరిసరాల మధ్యలో సువిశాలమైన వాతావరణంలో అనుభవజ్ఞులైన అధ్యాపకులచే డైరెక్టర్ అనపర్తి ప్రకాశరావు గారి నిరంతర పర్యవేక్షణలో అత్యుత్తమ ప్రమాణాలతో క్రమశిక్షణతో కూడిన విద్యను అందిస్తున్న సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. లైబ్రరీ, కంప్యూటర్ ఎడ్యుకేషన్, ప్రొజెక్టర్స్, హై అండ్ ల్యాబ్ ఎక్విప్మెంట్ తో పాటు రక్షణాత్మకమైన రవాణా వ్యవస్థను కలిగి ఉన్న నమ్మకమైన సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. ఎస్ఎస్సి వార్షిక ఫలితాలతో పాటు జాతీయ, అంతర్జాతీయ ఒలింపియాడ్లో అగ్రస్థాన ఫలితాలను సాధించడంలో దిట్ట. క్రీడలు మరియు ఇతర సాంస్కృతిక కార్యక్రమాలైన నృత్యం, సంగీతంతో పాటు క్రాఫ్ట్ వర్క్స్ లాంటి కళాత్మకమైన అంశాలకు ప్రాధాన్యత ఇస్తూ ఆర్చరీ, రైఫిల్ షూటింగ్, స్కేటింగ్, ఫెన్సింగ్ లయందు జాతీయ స్థాయి శిక్షణ కల్పించడం మాంటిసోరీ ప్రత్యేకత. పరిశుభ్రమైన పౌష్టికాహారం, అత్యంత పరిరక్షణతో కూడిన హాస్టల్ వసతి కలదు. మాంటిసోరీలో చదువు ఉన్నత విలువల కొలువు. మీ పిల్లల భవితకు మాంటిసోరీ భరోసా. అడ్మిషన్లకు సంప్రదించండి. మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ ఇంగ్లీష్ మీడియం, బ్యాంక్ కాలనీ తణుకు. మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు పచ్చటి పరిసరాల మధ్యలో సువిశాలమైన.
So we have defects called myopia and hypermetropia and presbyopia. So this is the defect of myopia. So we have already discussed that image will be formed on the retina of the eye. But for the person suffering from myopia, the image will be formed in front of retina. The image will be formed in front of retina. So for this persons we are using a correction. So we can correct myopia by using a biconcave lens. By using biconcave lens we can correct the defect of myopia. So by placing a biconcave lens, when the light rays are incident on the lens, they get to a point M. This point we call it as a far point. So how far he can see, this can be denoted by small d, sorry, capital D. So from here the eye lens can take the object and now the image will be formed on the retina. On the retina. Next hypermetropia. We know that hypermetropia also called as far-sightedness. Hypermetropia can also be called as far-sightedness. So for these persons the image will be formed beyond the retina. The image will be formed beyond the retina. So for these persons, in order to correct this defect of hypermetropia, we will use a biconcave lens. We will use biconcave lens so that the image will be formed on the retina. So here the point we denote as a H. This point we call it as a near point.
స్కూల్ రెసిడెన్షియల్ తణుకు పచ్చటి పరిసరాల మధ్యలో సువిశాలమైన వాతావరణంలో అనుభవజ్ఞులైన అధ్యాపకులచే డైరెక్టర్ అనపర్తి ప్రకాశరావు గారి నిరంతర పర్యవేక్షణలో అత్యుత్తమ ప్రమాణాలతో క్రమశిక్షణతో కూడిన విద్యను అందిస్తున్న సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. లైబ్రరీ, కంప్యూటర్ ఎడ్యుకేషన్, ప్రొజెక్టర్స్, హై అండ్ ల్యాబ్ ఎక్విప్మెంట్ తో పాటు రక్షణాత్మకమైన రవాణా వ్యవస్థను కలిగి ఉన్న నమ్మకమైన సంస్థ స్కూల్ రెసిడెన్షియల్ తణుకు. ఎస్ఎస్సి వార్షిక ఫలితాలతో పాటు జాతీయ, అంతర్జాతీయ ఒలింపియాడ్లో అగ్రస్థాన ఫలితాలను సాధించడంలో దిట్ట. క్రీడలు మరియు ఇతర సాంస్కృతిక కార్యక్రమాలైన నృత్యం, సంగీతంతో పాటు క్రాఫ్ట్ వర్క్స్ లాంటి కళాత్మకమైన అంశాలకు ప్రాధాన్యత ఇస్తూ ఆర్చరీ, రైఫిల్ షూటింగ్, స్కేటింగ్, ఫెన్సింగ్ లయందు జాతీయ స్థాయి శిక్షణ కల్పించడం మాంటిసోరీ ప్రత్యేకత. పరిశుభ్రమైన పౌష్టికాహారం, అత్యంత పరిరక్షణతో కూడిన హాస్టల్ వసతి కలదు. మాంటిసోరీలో చదువు ఉన్నత విలువల కొలువు. మీ పిల్లల భవితకు మాంటిసోరీ భరోసా. అడ్మిషన్లకు సంప్రదించండి. మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ ఇంగ్లీష్ మీడియం, బ్యాంక్ కాలనీ తణుకు. మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు పచ్చటి పరిసరాల మధ్యలో సువిశాలమైన వాతావరణంలో అనుభవజ్ఞులైన అధ్యాపకులచే డైరెక్టర్ అనపర్తి ప్రకాశరావు గారి నిరంతర పర్యవేక్షణలో అత్యుత్తమ ప్రమాణాలతో క్రమశిక్షణతో కూడిన విద్యను అందిస్తున్న సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. లైబ్రరీ, కంప్యూటర్ ఎడ్యుకేషన్, ప్రొజెక్టర్స్, హై అండ్ ల్యాబ్ ఎక్విప్మెంట్ తో పాటు రక్షణాత్మకమైన రవాణా వ్యవస్థను కలిగి ఉన్న నమ్మకమైన సంస్థ మాంటిసోరీ స్కూల్ రెసిడెన్షియల్ తణుకు. ఎస్ఎస్సి వార్షిక ఫలితాలతో పాటు జాతీయ, అంతర్జాతీయ ఒలింపియాడ్లో అగ్రస్థాన ఫలితాలను సాధించడంలో దిట్ట. క్రీడలు మరియు ఇతర సాంస్కృతిక కార్యక్రమాలైన నృత్యం, సంగీతంతో పాటు క్రాఫ్ట్ వర్క్స్ లాంటి కళాత్మకమైన అంశాలకు ప్రాధాన్యత ఇస్తూ ఆర్చరీ, రైఫిల్ షూటింగ్, స్కేటింగ్, ఫెన్సింగ్ లయందు జాతీయ స్థాయి శిక్షణ కల్పించడం మాంటిసోరీ ప్రత్యేకత. పరిశుభ్రమైన పౌష్టికాహారం, అత్యంత పరిరక్షణతో కూడిన హాస్టల్ వసతి కలదు. మాంటిసోరీలో.
Okay, so these are the defects and how they can be corrected. So myopia can be corrected by biconcave lens. Hypermetropia can be converted by using a biconvex lens. So what is presbyopia? So the person suffering from both myopia and presbyopia. So this defect we call it as presbyopia. So myopia and hypermetropia, they are connected by biconcave and biconvex lenses. Then what lens is used for presbyopia? Do they have to use both the lenses? No. So they uses bifocal lenses. They uses bifocal lens. In this lens, the upper part and lower part. So the upper part is concave and the lower part is convex. This lens we call it as a bifocal lens. So for the correction of presbyopia we use a bifocal lens which has two parts, upper part and lower part. The upper part is concave and the lower part is convex. Next, dispersion. Now one more property of light is dispersion. So what is dispersion? So we often observe rainbow in the sky. Dispersion. What is happening? Actually we get the white light from the sun. So white light is not a single color. It is a combination of 7 colors. It is a combination of 7 colors. This we call it as Vibgyor colors. Vibgyor colors: violet, indigo, blue, green, yellow, orange and red. So these 7 colors are mixed and they are formed as white color. So when if you have taken a prism and incident a monochromatic light, a single beam of white light, then it gets dispersed into 7 colors. So this process of dispersion, the process of splitting of white light into 7 colors, the process of splitting of white light into its constituent colors is called dispersion. Dispersion. So the rainbow is the example for dispersion. So when you have taken a single drop of water drop on a sunny rainy day, you can observe the formation of a rainbow in such a manner, and the angle between the red light and red and white is about 40 to 42 degree. In order to form a rainbow there must be angle between 40 degree to 42 degree. Next, let us see how the artificial rainbows are formed. So the artificial rainbows are formed in different ways. In laboratory we can take a prism and take a plank and place a small hole by using compass, and now take a torchlight and place the light here, so that through this hole where single ray enters into the prism, and make sure that you have wall on the other side of the prism, so that you can get a rainbow on the other side. So here we have observed that the light has been split into 7 colors. Okay, and you have an experiment in the ground that if you have taken a water pipe in your hand and try to stand facing the wall, and the sun is behind you. Now close the pipe with your thumb so that the water gets sprinkled, and when the light rays are entering into through the sprinkled water, you can observe the rainbow on the wall. And also in the classroom activity you have when you have taken a beaker of water and you have placed a plane mirror, half of the portion of the plane mirror, and you try to take a torch and incident the light through the water onto the plane mirror, so that you can observe the rainbow on the ceiling of your classroom. So these are the activities how you can form the artificial rainbows. Next we have scattering. One more property of light is scattering. So what is scattering? So the process of re-emission of light. The process of re-emission of light in all directions. In all directions. Re-emission means it is again emitting when it is entering into a molecule, and when the wavelength of the light matches with the wavelength of the molecules, the light again gets rebounds and distributed uniformly in all directions. This process we call it as scattering. This is the reason why the sky appears blue in color during mornings, white in color during noon time. So this is the reason why the sky appears blue in color during morning. So because of the presence of the N2O2 molecules. So we already know that the sunlight has white color, which is constituted of 7 colors, 7 major colors. Among that colors, the wavelength of the blue light matches with the wavelength of the N2O2 molecules, so that the blue ray gets scattered and the sky appears blue in color. And why it appears white in color? Why it appears white in color during noon times? Because as the day goes on, the temperature increases and the amount of vapor molecules, the amount of water vapor molecules increases, so that the light now passes through these water molecules and gets scattered, and it appears white in color. So this is the reason why the sky appears blue in color and why the sky appears white in color, because of the N2O2 molecules during the morning and the H2O molecules during the noon time. And in the present activity, we have about the graph, that is angle of incidence and deviation graph. Okay, this is the graph. This is the point of minimum deviation. At minimum deviation, I1 is equal to I2. This is the graph we have to learn. Next, electric current. Electric current. So in this electric current, we can define the current as the rate of flow of charge per unit area of cross section. So current is denoted by I Q by T. So the rate of flow of charge, per unit cross sectional area is called current. The units of current is ampere. So what is charge? How it flows? So the Drude-Lawrence theorem has explained about the flow of charge. So Drude-Lawrence theorem explains the behavior of conductor when it is in open circuit and when it is in closed circuit. When the conductor is in open circuit, that means in off position, the charges will move in a random direction. When this conductor is made to connect with a battery, that means the conductor is going to be a closed circuit. So now the charges come to an ordered motion. This ordered motion of charges, we call it as electric current. So this is quantitatively define as the rate of flow of charge, and the quantitatively we can define it as the flow of charge. The ordered motion of current, charges is called current. Next, when the charges are moving in ordered motion, they acquire some speed. So the speed acquired by the charges when they are in ordered motion is called drift speed. The equation for drift speed or drift velocity is Vd is equal to I by nqa. So I is the amount of current, n is the number of charges, Q is the charge of the charged particle, A is the cross-sectional area of the conductor. Cross-sectional area is, this is the cross-sectional area of the conductor. So this is the drift speed, equation for drift speed. Next, Ohm's law. So in an electric circuit, when a conductor is made to closed circuit, is connected to a battery, then we know that the direction of current is always from high potential to low potential. The direction of current is always from high potential to low potential, and the electrons in the conductor will move in such a direction opposite to the direction of the conventional current or the electric field. Okay, so this potential difference, the potential difference is maintained due to the battery. So when the potential difference is maintained, this will make the charge to flow in the conductor. So this flow of charge we call it as current. So due to the potential difference, there is flow of charge. This flow of charge will remain in the production of current. So V is directly proportional to I. V is directly proportional to I. So this is what stated by the Ohm's law. So Ohm's law states that at constant temperature, the current produced in the conductor is directly proportional to applied potential difference. So this is the statement of Ohm's law. And Ohm's, in order to remove the proportionality, we multiply with a constant called R, where R is called resistance, So V by I is equal to R, that is constant. That means we can define as the ratio of the potential difference and the current produced is always constant. So when you want to prove Ohm's law, we can prove V is directly proportional to I, or the ratio between V and I are constant. And this is Ohm's law. We have some limitations of Ohm's law. Ohm's law is not valid for gaseous conductors. Ohm's law is not valid for gaseous conductors. And Ohm's law is not valid for semiconductors like silicon and germanium. And Ohm's law is not valid for complex circuits. Ohm's law is not valid for complex circuits. And Ohm's law is valid only at the constant temperature. In the definition itself states that only at a constant temperature. The Ohm's law is valid only at a constant temperature. So these are the limitations of Ohm's law, and we have an activity to prove this. So take different cells, 1 volt cells, 5 dry cells, and connect the circuit. Place an ammeter here. Now tabulate the readings, serial number V by I. So ammeter is a device used to find the current passing through the conductor. It shows the current, amount of current. So first connect one battery, so that it produces some current. The amount of current will be shown in the ammeter. And next add another battery in the series. So now the voltage becomes double, 2V. And now the current also changes. Note down the reading of the current. Similarly, add on the batteries and note down the corresponding values of current. After having all these values, find the ratio between V and I. So what you can observe is their ratio is always constant, maintaining the conditions of Ohm's law. That means it is valid only at a constant temperature. Maintaining constant temperature, the ratio of V and I is constant. So if you have drawn the VI graph for ohmic conductors. Ohmic conductors are the conductors which follow Ohm's law, are called ohmic conductors. That means V must be directly proportional to current. So the graph will be linear. If you have taken a non-ohmic conductor in place of this, for example, you have taken a LED, the graph will be a curved graph. So for ohmic conductors, the graph between voltage and current is a linear, and for non-ohmic conductors, the graph for V and I is non-linear. Next, what is resistance? The opposition offered to the flow of current is called resistance. The units of resistance is ohm. Okay. And what are the factors affecting the resistance of a conductor? What are the factors affecting the resistance of a conductor? Do all the conductors have same resistance? No. So what are the factors affecting? The first one is nature of the substance. Nature of the substance. The second one is the temperature. We have already discussed the temperature. The third one is the length of the conductor. Length of the conductor. And the fourth one is cross sectional area. The fourth one is cross sectional area. So these are the four factors that are affecting the resistance of a conductor. Okay, for this we have 4 activities in the textbook. They are important, so look at all the 4 activities. And what the conclusion is, the resistance is directly proportional to length of the conductor, and the resistance is inversely proportional to cross sectional area of the conductor. And from these 2 equations we can write R directly proportional to L by A. In order to remove the proportionality, we multiply with a constant called rho. It is rho L by A. So where rho is proportionality constant called resistivity. Resistivity or specific resistance. Resistivity or specific resistance. That means we are giving a specific value of resistance. So resistance is the opposition offered by the conductor irrespective of the length of the conductor, irrespective of the cross sectional area. But resistivity, the specific resistance, is the resistance of the conductor. It is the resistance of the conductor for the conductor having length 1 meter and unit cross sectional area. So it is the specific resistance. It is the resistance of a conductor for unit length and unit cross sectional area. So from this we can write it as rho is equal to RA by L. So rho is equal to area is 1 meter square and length is 1 meter. So 1 and 1 goes cancel. So rho is equal to R. So the specific resistance is nothing but the resistance of the conductor for unit length and unit cross sectional area, and the units of resistivity is ohm meter. The units of resistivity is ohm meter. Now let us see the series and parallel connection of resistors. Series and parallel connection. Let the resistance be R1, R2 and R3. We know that in series connection the voltage gets distributed across each resistor and the current remains same. The same current flows through the circuit in a series connection. So we can say that there is a voltage drop of V1 at R1, V2 at R2 and V3 at R3. So what we can say is V is equal to V1 plus V2 plus V3. So according to Ohm's law, V is equal to IR. The Ohm's law can be remind with this triangle V I R. So V is equal to I into R. I is equal to V by R. R is equal to V by I. This is the relation between voltage, current and resistance according to the Ohm's law. So according to Ohm's law, V is equal to I into R. So this is I into the equivalent resistance R equivalent. V1 is I into R1, I into R2 plus I into R3. So I can observe that I is common in this factor. So I into R equivalent is equal to I into R1 plus R2 plus R3. I and I gets cancelled. So I can write R equivalent is equal to R1 plus R2 plus R3. So in series connection of resistors, the total resistance is nothing but the sum of individual resistances. The sum of individual resistances. Next, let us see the parallel connection of resistances. Parallel connection of resistors. R1, R2 and R3. So in parallel connection, we know that the current gets distributed. The current gets distributed. So I1 goes up, I2 and I3. So I1 current goes through R1 resistors, I2 current goes through R2 resistor and I3 current goes through R3 resistors. So from this I can write I is equal to I1 plus I2 plus I3. What is the formula for I? I is equal to V by R. So it is V by R equivalent is equal to I1 is V by R1 plus V by R2 plus V by R3 and V common, so V gets cancelled. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So what we can say? We can say that the reciprocal of R equivalent resistance is equal to the sum of the individual the reciprocal of individual resistances. Okay. Next. Conversion of 1 kilowatt hour. 1 kilowatt hour can be converted expressed in joules. So 1 kilo means 1000 watt is equal into 1 hour is equal to 3600 seconds. So what I can write 36 into 1, 2, 3, 4, 5 into 10 power 5 watt second can be expressed as a joule. So I will write it as 3.6 into 10 power 6 joule because 10 power 6 can be expressed as mega. So this is 1 kilowatt hour can be expressed as 3.6 into 10 power 6 joule or 3.6 megajoule. Okay, next let us discuss about electromagnetism. Electromagnetism. So before 1820 it has been discussed that electricity and magnetism were different fields, but with the Oersted experiment it has proved that electricity and magnetism are related. So he has proved that a current carrying conductor will produce a magnetic field around it. With an experiment he has proved that a current carrying conductor will produce a magnetic field around it. Okay, this magnetic field direction can be explained by Fleming's right hand thumb rule. Fleming's right hand thumb rule. If a conductor is taken here, place your thumb in the direction of current such that your curled fingers will show the direction of the magnetic field. So this is into. So if this is into, this side will be out of. So we can if the direction of the current is in upward direction, the direction of the magnetic field is anti-clockwise. If it is downward, then it will get reversed. So now it is clockwise direction. So if the direction of the current is upward direction, the magnetic field is in anti-clockwise direction. If it is downward direction, it is a clockwise direction. So by using the Fleming's right hand thumb rule, we can find the direction of the straight current carrying conductor as well as circular coil. A circular coil which carries a current in such a direction. So here the curled fingers will show the direction of the current. So this is the direction of the current. The thumb will show the direction of the magnetic field. So this thumb indicates north pole. This north pole is inside. So what we can see is south pole. Okay. Or you can explain as the thumb is north pole and inside the magnet the direction of the magnetic field is from south to north. So in the same manner it can be explained. So if it is in this direction, this will be north pole. Okay. If you have taken a solenoid, so this is the curled fingers will show the direction of the current. So this will become north pole and this will become south pole. If this the direction is in downward direction, the poles will be reversed. So the Fleming's right hand thumb rule will explain about the direction of the magnetic field by using Fleming of straight current carrying conductor, a circular coil and a solenoid. Okay, next. what happens when a unit charge is placed in a magnetic field. For example, there is a magnetic field which is going into the board. So this is the direction of the magnetic field. So this can be explained by Fleming's right hand rule. So in this right hand rule, the thumb shows the direction of current, the index finger shows the direction of thumb shows the direction of force, index finger shows the direction of current, and the middle finger shows the direction of the magnetic field. So now place the magnetic field middle finger into the board, and this is the direction of current and this is the force. So when a charge is introduced, when a charge Q is introduced with velocity V into magnetic field B, next, so this is the magnetic field, this is the direction of the charge, and this will be the direction of the force, magnetic force. So this is the direction of the force. So the force is experienced in upward direction. Now here the direction changes. Now left side. Again changes. Now downward. So when the charge enters into the magnetic field, it continuously moves in anti-clockwise direction. Anti-clockwise direction. If I have changed the magnetic field outside, then it goes in a clockwise direction. So you can find the radius. So as it experiences centripetal force, it is mv square by r. It is bqv. The magnetic force is F is equal to BQ V. V and V gets cancelled. So the radius is equal to mv by BQ. So this is the radius of the charge which is moving inside the body. Next, velocity is equal to the displacement by time. Okay. R is equal to mv by BQ. V is equal to 2 pi into mv by bq into t. So if t comes here, t is equal to 2 pi m by bq. So you can write in this manner. Next, what happens if infinite charges are moving in the conductor? So if one charge is gone, the magnetic force is equal to BQV. If infinite charges, that means a conductor of length L carrying current I is placed in a magnetic field B, then the magnetic force is equal to F is equal to BIL. So, okay, if it is perpendicular, it is BIL sin theta. This is the angle between the magnetic field and the current. So the electric motor is a device which converts the electrical energy into mechanical energy. So what is the principle of electric motor? The electric motor works on the principle that when a current carrying conductor is placed in a magnetic field, it experiences some force. Okay. Next, electromagnetic induction. So the Faraday's law explains that the Faraday has explained that if I have taken a coil and connected to a galvanometer, next and you place a magnet, so that when you move the magnet in the coil, the galvanometer gets deflected. That means with the movement of the relative motion of the magnet and the coil, there is some relative motion of there is some current induced in the coil. This current is called induced current. This process of inducing current is called electromagnetic induction. So the generators works on the principle of electromagnetic induction. According to Faraday's law, what you can say, the rate of change in flux is directly proportional to the EMF induced in the coil. And the Lenz law has corrected EMF is equal to N into delta phi by delta t. This is what stated by Faraday's law, and the Lenz law has corrected this that the current induced in the coil in such a direction opposes the change in flux. So it was corrected by Lenz. So this is Lenz law. So the working of AC generators and DC generators are based on the electromagnetic induction. So the generators are the devices which converts mechanical energy into electrical energy. Thank you.
ఉప్పొంగి ఓ తెలుగు బిడ్డ స్వాతంత్ర్య విప్లవ సమర రంగాన స్వాతంత్ర్య విప్లవ సమర రంగాన ప్రభుత్వపు నీడ సీమ దొరలా చాడా ముంగుతూ బ్రతుకుటే జాతికే సిగ్గురా జాతికే సిగ్గురా ముక్కోటి తమ్ములను ఒక్కటిగా నిలబెట్టి మెడబట్టి తెల్లోళ్ళ నెట్టి గెంటాలిరా మెడబట్టి తెల్లోళ్ళ నెట్టి గెంటాలిరా పొంగరా ఉప్పొంగి ఓ తెలుగు బిడ్డ స్వాతంత్ర్య విప్లవ సమర రంగాన స్వాతంత్ర్య విప్లవ సమర రంగాన నాటి చంద్రుని తెలుగు విక్రమ ధాటి నాగులేటి నాగ పుగ పుగల పగ ఘాటు నిరుత్తమ రౌద్ర రోషాన లజ్జాల శ్రీ మహాశక్తిరా శ్రీరామ రక్షరా శ్రీ మహాశక్తిరా శ్రీరామ రక్షరా పొంగరా ఉప్పొంగి ఓ తెలుగు బిడ్డ స్వాతంత్ర విప్లవ సమర రంగాన స్వాతంత్ర విప్లవ సమర రంగాన పరుగు కృష్ణవేణి ఉరక పర్వతాలే రగులు మన్య తేజముతో తెలుపు గట్టే నీకు నివ్వాడు లెత్త కొడపట్టి చేపట్టు జయము కొనగాన కొడపట్టి చేపట్టు జయము కొనగాన కొడపట్టి చేపట్టు జయము కొనగాన
Good afternoon to all. Now I will explain all chemistry chapters. So listen carefully and note down the points, main points. So first I will explain acids, bases and salts. So we know that the properties of acids, bases and salts. Let's see acids properties. Acids have sour taste and they changes blue litmus to red litmus, and acids produce H plus ions when they are dissolved in water, and examples for acids are HCl, HNO3, H2SO4, so on. And bases have bitter taste. Bases have bitter taste, and bases changes red litmus into blue litmus. And next bases produce OH minus ions. OH minus ions, and examples for bases are NaOH, KOH and MgOH twice. Next, after that, salts. Salts are, how salts are formed? Salts are formed by the combination of acids and bases. Salts are formed by the combination of acids and bases. This is some brief explanation about acids, bases and salts. Next I will discuss about indicators. Indicators. How many types of indicators? Indicators are classified into two types. Indicators are classified into two types: natural indicators and synthetic indicators. So natural indicators, example: litmus, turmeric, so on. And synthetic indicators, we have two synthetic indicators: phenolphthalein and methyl orange. Phenolphthalein and methyl orange. So now we will see the colors of phenolphthalein and methyl orange indicators in acidic and basic mediums. In examination point of view, they will ask the colors of these indicators in acidic or basic medium. So one see. So phenolphthalein in acidic medium, what is the color? Colorless. Phenolphthalein in basic medium, what is the color? Pink color. Similarly, methyl orange in acidic medium, color is red color. Methyl orange in basic medium, what is the color? Yellow. So these are the colors. Once again, phenolphthalein in acidic medium, colorless. Phenolphthalein in basic medium, pink. Methyl orange in acidic medium, red. Methyl orange in basic medium, yellow. So this is information about indicators. Next, another type of indicators are there. That indicators are olfactory indicators. Olfactory indicators. What is the definition of this olfactory indicators? The substances which changes their odor. Odor means smell. The substances which changes their odor in the presence of acidic or basic medium. So example for olfactory indicators are onion pieces and clove oil. One more. It is vanilla essence. These three are called olfactory indicators. Next, after this, let's move on to next topic. Now activities. In this, the main activities are lab activity, activity 4, activity 7 and 16. So now I will explain that activities one by one. Lab activity. Lab activity means the reaction between metal and acid. The reaction between metal and acid, then what substance are formed? Salt and also hydrogen gas is liberated. Hydrogen gas is liberated. So maximum metals liberates hydrogen gas when they react with acids, except copper. Why copper cannot displace hydrogen from acid? Copper is least reactive than hydrogen. That's why copper cannot displace hydrogen from acids. So remaining all metals displace hydrogen from acids. That's why all metals produce hydrogen gas when they react with acids. This is lab activity. And after this, activity 4. In this activity 4, sodium carbonate, that means metal carbonate or metal bicarbonate reacts with acid. For example, sodium carbonate reacts with 2 moles of HCl. It gives salt plus water and CO2 gas. So here we will use either carbonate, metal carbonate or bicarbonate. Bicarbonate means NaHCO3, sodium bicarbonate. If you will use sodium bicarbonate, the products are same: NaCl plus H2O plus CO2. So these two reactions. In examination point of view, if they will ask metal carbonate with acid means we have to write first equation. If they will ask metal bicarbonate with acid means second equation. We will write second equation for this activity. This is activity 4. Next one. So activity 5 are important one. It is neutralization. What is neutralization? Neutralization means the reaction between acid and base. The reaction between acid and base to form salt and water. The general representation of this reaction is acid plus base gives rise to salt plus water. It is the general representation of neutralization reaction. So, what are the main examples? We have to remember two examples for this equation. Example 1, HCl plus NaOH gives rise to NaCl plus H2O. One more equation, HNO3, it is nitric acid, HNO3 plus KOH, potassium hydroxide, gives rise to KNO3, it is salt, plus water also formed in this equation. These two equations are examples for neutralization reactions. Examples for neutralization reaction. This is about neutralization. After this, let's move on to next activity, activity 7.